question that drives us, Neo.
How do we get out of ME2110 with a passing grade?
Try to understand the truth.
What truth?
That you aren't really taking a 3-credit-hour class.
It is a class that you can't avoid in your schedule to lower your GPA. You are a student enrolled in a competition for your grade. The Matrix is a challenge, Neo. That challenge is only one of several. I'm trying to help you get out of this class, Neo, but you have to build the machine. You're the one that has to write the final report. I've seen a team knock pills right out of the right side of the Matrix. Engineers have built entire machines for them to get disqualified in the end. Everyone who has not passed this class has switched majors. Where they have failed, you will pass.
What are you trying to tell me? That I can bring Morpheus all the way back to Zion?
No, Neo, I'm trying to tell you that if you have enough points to win, you don't have to.
The competition is set up on a 7-foot by 7-foot arena, which is divided into 4 home zones, shown as black, blue, white, and yellow, one for each of the teams competing. Each team is given a 30-inch by 30-inch starting zone to place their machine in. Once the competition begins, there are 4 tasks to be completed within 40 seconds, each task contributing to the team's overall score. First is engaging the Sentinel by removing it from the home zone. Second is program module collection, in which the modules are captured and secured in the home zone. Third are the pills, which must be correctly placed in both red zones inside the matrix in the center of the arena to maximize points. The final task is rescuing Morpheus from the matrix once the shield is lowered and moving him to a different portion of the arena.
Based on the competition information given, we found that the most points a machine could be designed to score is 186. We used this table throughout the design process to weight the pros and cons of focusing on each subsystem.
The first step taken in the design process, once we understood the problem, was creating a function tree. The function tree shows the main functions at the top, which is to win the final competition, and then the sub-functions under that. Some important sub-functions include sense beacons and trigger on time. These functions would help us avoid disqualification and ensure the consistency of the pill subsystem. We then took the functions from the function tree and used them to create a house of quality. The house of quality shows both the competition and engineering requirements and relates them. The relative weights, shown at the bottom, identifies the requirements with the largest impact on the success of the machine. For this project, those having all the sub-assemblies, which would maximize the possible number of points. Then, being able to fit in the box and running autonomously consistently. Meeting these 2 requirements greatly reduced the chances of the machine being disqualified from the competition. The third planning document is the morph chart. This chart shows possible solutions for the subfunctions of the function tree. This design uses foldable L-shaped arms that drop behind the programming modules. It pulls them in once the actuators retract. Both the pills and the Morpheus rescue arm are extended into the matrix using a scissor mechanism that is also mounted on a vertically pivoting base. The Sentinel is retrieved with a hook that is dropped just behind it and pulled back separately from the arm that placed it. Although this design has an efficient use of space, its major downfall is the lack of vertical rigidity when the scissor mechanism is fully extended.
The second alternative design has the arms for collecting the programming modules completely folded for increased speed and utilizes a multi-layer drawer slider system to reach the matrix. The pills are delivered to the matrix with 2 buckets that each hold 2 pills to be placed in each red zone. The arm located on the top of the design is used to slide Morpheus into the team zone and off the pedestal. The bucket delivery design for the pills has slightly disadvantages, with the front of the buckets falling backwards, putting the pills farther from the lip of the matrix. The Morpheus retrieval arm also lacks the ability to retrieve Morpheus all the way to the home zone, limiting the scoring potential of this design.
Alternative Design 3 is shown here in the open position. Like the previous designs, the arm and sweeper systems extend first to capture and collect the programming modules. As the drawer slider extends, the center bar below pushes the Sentinel forward into the blast zone. At the extended state, pills are placed into the 2 red sections of the matrix. They're released by a wheel that lets 1 pill roll out at a time. The Morpheus bar opens up over the matrix and then pulls back to knock Morpheus into the home zone before the whole system retracts back to the starting area. The biggest downfall of this design is that Morpheus can't be brought all the way back to the starting zone. He can only be knocked into the home zone.
Design 4 features a claw mechanism for the retrieval of Morpheus. The mechanism for delivering the pills mimics a merry-go-round, which spins as it delivers the pills into its appropriate zones. The sentinel is engaged using a hook mechanism under the main arm to sweep the sentinel back into the home zone. All of these mechanisms rest on the same ejecting arm, which uses a door slider. The mechanism used to gather the program modules is a wedge that swings down from above the arms to knock the modules into our zone. The mechanism rests on an arm that swings out, rotating from a joint at the base and another midway up the arm.
Final design based on testing and preliminary competitions, the final design of the machine had a few iterations. The final design used in the competition is shown here. The first subsystem to deploy are the programming module arms. Each arm is hit by a pneumatic actuator so that it falls forward. As it falls, the rest of the arms unfold with the help of mousetraps. The arms fall just beyond the programming modules and then are pulled back in by the actuators to move the programming modules into the home zone. When the arms are hit out, the drawer slider in the center is able to extend forward to the matrix. As it moves, the wedge for the sentinel passes over the sentinel and begins depositing pills. The pills are stored in a PVC tube with 2 solenoid gates. A long-arm sensor detects the beacons as the matrix rotates. When a red zone is connected, the first solenoid gate is opened to release 2 pills. Then for the next red zone, the second gate is opened. The slider then egresses to double the pill score using a motor that turns a spool and wraps up a string. While egressing, the wedge will pass under the sentinel. At this time, another spool and string mechanism is used to raise the wedge and sentinel so it can clear the ramp up to Zion. The design does not attempt to retrieve Morpheus because the risk of being disqualified outweighs the possible point value.
In each preliminary competition and the qualifying competition, the machine placed first, largely due to the consistency of the pill system. The success in the qualifying round gave Neb a high seed in the final competition, 13th out of 70. Neb's performance in the first 2 rounds was unusually bad. In round 1, the drawer slider didn't reach the matrix, making the 80 points from pills impossible. Neb scored just 8 points, but because of the high seed, still placed second in the field of 4 teams. Since second place guaranteed moving on to round 3, we used round 2 as a trial round to diagnose the problem. We couldn't find any obvious problems, but made a modification in setting up and performed much better. In round 3, Neb performed successfully. All 80 points from the pills were scored, 1 tennis ball was retrieved, and others were blocked from other teams, and the sentinel was removed for the first time. Neb placed first in this round. In round 4, Neb performed well again, placing first and moving on to round 5. In the quarterfinals, Neb didn't perform quite as well, but still placed second. In the semifinals, Neb performed very well and placed second again. We moved on to the finals with the second highest score of the 4 teams from semifinals. In the finals, Neb only scored points from the pills. The arms were too slow compared to the direct competition to retrieve any programming modules. If Neb had successfully removed the sentinel, it would have placed second. The machine pulled the sentinel into Zion, but not completely. The small part that was still in the home zone meant a loss of 13 points, while the machine only needed 9 points to place second.
Overall, we are satisfied with the performance of Neb. If we had more time, we would have liked to continue to speed up the arms used to capture programming modules and improve the consistency of the Sentinel remover. There have been many takeaways from this class besides how to build a machine. We learned the importance of starting work early and planning ahead. By building onto the same base each week and not rebuilding each subsystem, we saved a lot of time. We also learned the importance of prioritizing. By perfecting our pill subsystem, we had good odds at moving on through each round of the competition. If we had perfected the program module arms, our point capabilities would have been lower, and our odds of making it to the finals would have been worse. Thank you for your continued support and good sportsmanship. Any questions?